Hello everyone, I'm Doug Brown, businessparamedic.com, and today we're going to talk about another tool in your kit bag. This one is a risk management tool called Crystal Ball. Crystal Ball is an add-on to Microsoft Excel. If you've purchased it and added it in, you can see it up here in the ribbon where it says Crystal Ball. We'll work through an exercise today to see how it works. This is a very simple one showing a series of years. In this case, there are the expected inflows and outflows by year. What Crystal Ball does is help you create a distribution around your expected values. What I've done to make it simple when you're working the tool is to get the data that you're going to use and put it here in the spreadsheet, so you're not juggling different pieces of paper. Once you've got your spreadsheet set up, it's pretty simple after that. Now, before you mess around with the Crystal Ball tool, it's a good idea to leave your original data in place. So what you can do with Excel is create another sheet to hold it. You can create a copy and make sure you check this Create a Copy box, or you'll just be moving the sheet, and then rename the tab so you know which one you're working on. And now we can simply go in and make some assumptions about our estimates. One of our biggest risks in any business venture, including our projects, is that we use point estimates without realizing that there is truly some variability. So to use the tool, we simply look at the data item we want to put a distribution around, in this case E5, and then we go to the Crystal Ball ribbon and define the assumptions. In this case, it's warning me that if I had anything in the model, which I did from working the exercise before, it's going to reset it all. That's why you want to save key versions in another tab. Now I accept that and choose the Beta Pert selection because it's not exactly the normal curve we're used to. It's going to ask me what the minimum and maximum are, and I can fill that in easily because I can see them on the left where I set them up earlier. Assuming I don't make any typos. So 30,000, 50, 60. When I enter these parameters, you can see it's off-center and not your typical normal curve. You close that, and you see that now I have a green block in that cell showing that we have entered an assumption. So now we can move them down to the next cell and do the same thing. You can pick any distribution you want depending what the actual data is. Now there's one I want to warn you about, uniform. Sometimes, depending on how you set up Crystal Ball, that may be your default. Now look at the little icon, which means there is no variation around the mean. It's all the same number. Let's take a look at it bigger. The probability of every answer is the same, so there's no point using that. So let's go back to our Beta Pert, and we'll enter 95,000, 120, and 136. And by the way, how did it know what my most likely estimate was already? Because I already had that as my initial estimate, which is what I'm building the assumptions around. So once you get this in, hit enter to apply it. Make sure it looks about right, and we're ready to do the next one. I'm not going to bore you with doing it 5 more times, so we'll jump forward. We've made some progress here. Now there are other paths to do this. You can just click the Define Assumption buttons, and the chart sample all shows up in the larger window, and then you click the one you want. Now what happens if I make a mistake and mess this up? Let's say I don't put in enough zeros here, and then maybe again here. Now some errors it's going to pick up for you, like the maximum is less than the others, so I can't use that and I have to fix it. So I do. And whoa, what happened here? Well, it was okay with the computer, but my eyeball can tell it's not right. So we need to fix that too. Now let's do another one using the beta Pert, and see once again it goes pretty quickly if I've already got my data set up, as we did here. Now instead of clicking the OK or Enter button on the window, I can just hit the Enter key on my keyboard, and you see the shape changed, but my cell didn't turn green, so I needed to hit the OK button, and then it registered. Now we have one more here. Pick a curve, enter the data, and hit OK. So now we have all our assumptions about our estimates done with distributions around them. It happens that we used all the same distributions, but the curves are a bit different based on what we thought the minimums and the maximums would be. Now here's another part of our analysis that depends on something we can't be sure of, the inflation rate. Now inflation we think probably does move around a normal curve. And when we pick that, the questions are a little different. This window wants to know what the mean is, and we already decided 2% was our estimate. But it also wants the standard deviation. Now this is tricky because our units are in percentages. So if you just entered 33, it means it thinks you mean 3,300%. If you just do 0.33, which you think would be right, well then it thinks you mean 33%. So we have to make sure we put in 0.33 in the percent sign. Now it gets it right. And now you see another green box in the inflation estimate cell, and now we know that we have a probability distribution around the inflation rate. But there isn't one around the hurdle rate. Well, what is that? The number you're going to use depends on where you're coming from. It's not a distribution, it's just a hard number that's established by the organization as whatever they think an acceptable margin rate is. So it's not probability based, it's just a decision on their part. Now what are we going to do with all this? Well, what we want to know is, what's this going to do to our forecast? Given all the variability that exists in these cells here. Now we didn't do this for the outflows because we think we know what our costs are, because we thought our estimates did a good job on that part. Now that's probably true with financial estimates, but if you're coming in from the project management world, you know there's plenty of variability in the cost side too. We don't need to take the time in this demo to fill all these out again in the exact same way, but in your real situation, you may well want to do that. So we did all this work because what we really want to know is what's the likelihood that this outcome of our initial estimate would be a $17,000 profit? What happens if we take into account all this variability? So instead of assumptions, let's use this other button here and define a forecast. We'll call it NPV Demo. In this case, the units are dollars. And there are more details if we need them. This double arrow icon up here expands and hides the detail section. You typically want to have the automatic choice turned on. So now we save it. Now I have a blue box showing that this is the number that's going to be simulated. Now up to this point you can do all this in Excel without the crystal ball add-in. Excel has statistical functions, but you'd have to go create 200 or 500 rows of fake data to represent the variability. And you'd have to make sure the fake data did have the right variability to present the distribution you thought was correct. And that's for each item. So here's the big value out of crystal ball. So right here in the run section of the crystal ball ribbon, all we have to do is set up the number of runs we want. We say 1,000. And press start. And off it goes, 1,000 runs, and the results are right there. Let's bring that results page forward so you can see it better. I'm not sure why I did it twice. I think it's left over from the last time I ran it. So let's close it down and run it again. Now you have to be careful because if you click on the control panel, it takes the simulation windows away. But we can just do it again. Now watch for the shape of the curve changing while it's running. That's where the variability is kicking in. So now this time let's grab the image instead of clicking on it, and then we can bring it forward. Remember, the outcome we were predicting was 17,000. 17,000 is kind of the mean, more or less. But there are lots of cases where I don't make that much. And there's quite a few where I lose a lot more. Now, in some cases I do make a lot more. Those are the ones the salespeople talk about when they're selling you on what you might be able to achieve. Now, if I want to change my analysis, make sure you save this one using a screenshot or something, and we'll put it away. Now, another area we're concerned about might be the inflation rate. Remember that it goes into the calculation of the outcome, but we need to simulate it in the cell where it comes from, not where it's being used. So we can change it from 2% to 4%. We can also change the distribution, and it warns us it'll change the answer. Now notice that the window didn't pick up that I had changed the estimate from 2%. We need to go back and correct that to 4%. Make sure we get the entry right. This time, as remember, 4 means 400%. So we get that right. And we look at the graph picture to make sure the mean is at 4%. Now when I run it again, watch that shape changing. If you remember the picture we had before, now we're nothing like that. This one is much spikier. And where's our estimate? Losing 7,000? Looks like it's offset from the center of mass. More like losing 10,000, not the 7,000 of our estimate. And about a quarter of the time, we might lose 20,000 or more. Your stakeholders will get the idea when you show them the graphs. And that communication is what Crystal Ball does for you.